Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. We have a pump that is pumping water vertically up 16 meters. The pump has 8 horsepower in the shaft. The mechanical efficiency is 83%. We want to find the maximum volume flow rate of the water. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. Next, list all the given variables and find the unknown. So 83% efficiency for the pump, 8 horsepower, and 16 meters. Step 3, find the volume flow rate formula, V dot. So here's how we derived it. Here's the long explanation. So we know that the elevation is changing. So that's gonna lead us to potential energy. There's no changes in velocity and pressure. So that means the mechanical energy is equal to potential energy. And then we've got gravity multiplied by elevation is unitless. We know the mass flow rate and then gravity and elevation for the given mass flow rate. So here's the formula. And from there, we just divide the potential energy from the mechanical power. So we bring the potential energy to the other side of the equation, which will leave us with V dot. Okay. And mechanical energy in this case is the power of the pump, which is the 8 horsepower. So we get this formula that we derived from this equation. Step 4, find the formula for the power of the pump that is useful. So that is the efficiency multiplied by the power of the shaft in the pump. So 83% multiplied by 8 horsepower gives us 6.64 horsepower. Okay, so step 6, now we can find the volume flow rate. So we just plug and play. 6.64 horsepower divided by 1,000 kilograms per meter cube. That's the density of water. We're assuming it's fresh water. And then we've got gravity, 9.81 meters per second squared. And then our height is 16 meters. And then we need to convert our horsepower into watts. Then we need to convert our watts to Newton meter seconds, and then we need to convert Newton into kilogram meter per second squared. So the units will cancel out and we'll get meters cubed per second. So the final answer for the volume flow rate is 0.031927 meters cubed per second. So this is the maximum flow rate since the frictional effects are ignored. In an actual system, the flow rate of the water will be less because there is friction in the pipes. Disclaimers: the method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things just happen. You can do this by using snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar and then open up the program. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program. Click on video option, click on new. Left click and drag the rectangle to cover your YouTube screen. This is just an example. Hit the start button, wait for the countdown. In snipping tool, hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. Until next time, before we leave, if you want to support me, become a member or drop a super thanks. Alright, see ya.